I believe now it's time for more shots of security, reverse engineering, and maybe one new technology that will ease your life. Today, our presentation is about network automation, and my name is Oma Isa, and here with me, Wojtek. We are from ERNW. This is a company, a security company based in Heidelberg, Germany, and today we will be speaking about network automation and specifically autonomous networks. So what is it all about? Haven't we all had this problem that you send someone to the site and he doesn't have the running configuration for your router? Or you had this typo mistake that you kept troubleshooting for days and days after each other? What if I said to you that everything can be automated for you? What if I said to you that now your switches or your routers can be just like plug and play, like a USB? Everything will be automated for you. Everything will, you will have a basic configuration. You don't have to think about it anymore. Well, this would be the main part or the first part of our presentation today. If you are that guy who would like to be always in control of your network, the second part of this presentation is for you. In this part, we start by reverse engineering the Cisco protocol. We start by understanding the value and the significance of each and every byte within our packets. If you are the security guy, if you would like some fun, see some vulnerabilities, crack, and take the network down, the last part of the presentation, the third and the final part, is for you. We have lots of vulnerabilities today, and we have lots of attacks, and yeah, we hope you enjoy it. So how did it start? In 2001, IBM had this idea that systems are getting more and more complex by time, and it would be nice if we have systems that are smart enough to manage themselves. Well, what does that mean? They had the idea that we want systems that can optimize itself, optimize the running resources, configure itself. You don't need to configure anything in it, and also secure itself. It knows what the attacker coming and stop it. Well, it sounds to be a little bit optimistic, but the guys from IETF and Cisco, starting from 2014, started to think about deploying such a technology and making it from just theoretical world into a real commercial brand working. So what did they do? They started by 2014, the IETF and Cisco guys, writing the documentation for autonomous networks. What's their idea for that? They had the idea that we will only have one device, which we will call it here register. We will just configure 5 commands on this device. And after that, anything connected to this device will be configured on its own. There is no more hassle about configuring, about working, about doing anything. No, just connect, and everything connected after that will be configured. So, okay, if this device I have to write 5 commands on it, what about the others one that I connect to? Well, nothing. If it's a new device, you don't need to configure anything at all. And if it's like an old device that has already a configuration file, all what you have to do is just run a single command to enable the autonomic services. Somehow this sounds a little bit optimistic. This can ease lots of problems. So let's see this into practice. What I'm trying to do here that I just asked Wojtek here with me to bring a brand new device. This is the one that we have here. And as you can see here from the presentation, I'm asked to go to the configuration dialog mode. It's for the people who are used to Cisco. This what you see once you buy a brand new device, or you just remove all the configuration on it. So that's what I did here, and all what I will try to do now is connect this device to the one device that has 5 commands to the register and see whether it will be configured or not. So what we have done here is that we just connected it, and we will see whether the device will get the, here the configuration starts. Please note that we haven't configured anything. Our hands are just up like that. We didn't put anything on it at all. And everything starts to get configured on this device. From what we can see on the slides here, that I can see that some interfaces start to become up. I can see an autonomic network interface started to become up. I can see here also that there are new neighbors, a new interface called ANI. All of that we will speak about in our presentation. But what I would like also to stress out here that we haven't done anything. We just connected this device. And here we are seeing more and more configuration being done on this device. I started seeing that there are some VRFs and some certificates and some keys being generated. So to have a rough idea about what's configured on this device, I'll just issue now a small command like by writing show IPv6 interface brief. And we can see here that now we have like 3 new interfaces configured on my device. And they have already gotten even their IPv6 address. You don't need to configure anything here. One interface, which is like the loopback 100,000. We have the tunnel interface, and we have an autonomic network interface. This is a virtual one. Once we see like we have a tunnel interface, that leads us to think that maybe there is security, we saw some certificate and we saw some keys. So if you would like to know what's the protection mechanism of this tunnel, we will write here show autonomic control plane. And once we type something like this, we see that the protection mechanism is something called DIKE. It's not even IPsec, the thing that we are all used to. No, it's also brand new technology from Cisco. So Cisco had this idea to put everything automated on your machine. There are no commands that you can alter here. There is nothing you can do to change even the protection mechanism of the tunnel. DIKE doesn't have even a configuration commands on Cisco routers. So everything will be automated for you and everything will be configured for you. Well, this sounds to be a little bit interesting, but let's try now to understand what happened to these devices and what is like this tunnel interface and what's DIKE and stuff like this. So if we go back to the presentation, first we speak about what are the implications of what just we have seen here. First, your device now is just plug and play. You don't need to configure anything. You'll just get a basic configuration by just connecting to one device. If this is a brand new device, you don't have to connect anything. Just think about this. You're just sending the technician to the site, connect the router, and he goes home. And now you have full control and your device is working. If it's one of the devices that used to have an old configuration, all what you have to implement is just one command, which is called autonomic. Well, in order to understand the phases of communication we have seen, Cisco divided it into 3 phases. First phase, which they call like a channel discovery, where we're detecting devices on layer 2. After that, adjacency discovery, where we go to layer 4 and start discussing or sending some certificates. And finally, a secure channel when we saw DIKE. In order to dive a little bit deeper into this, we can say the following. What's the function of channel discovery or layer 2? It just tries to send probes. This register is sending probes every now and then saying like, is there any reachable autonomic device around? And once it gets like an answer or reply from it, it just finishes this phase. It's just a very simple and basic phase. The devices need to be reachable on layer 2. After that, we go to the adjacency discovery. In this phase, the register starts by saying, well, I support this autonomic network, I support this domain, this is my network name, and would you like to join me or not? Well, for this, because we are speaking about brand new devices, there is no configuration on them, so the register has a whitelist of the serial number of the allowed devices to join. So if you are allowed to join, or if you are rejected, then sorry, we will be just like friends or neighbors on layer 2 level. But if you are just allowed to join, okay, perfect, we will issue a certificate for you. A certificate can be understood as an ID that you will get, that now you are part of my domain, you are part of my network. Once you get a certificate from a specific register, you cannot communicate or you cannot like be a part of another domain. It's just one single domain that you can be part of. All of that is done like on UDP service on port 4936. To have a small diagram in order to understand what we have just described about the adjacency discovery, we can see it as the following. The register starts by sending like, hey, I support domain X, I support ERNW.DA, and I'm asking if you would like to connect to mine. If the enrollee just responds back with an empty domain name, it means I would like to join. Else, it means I am a part of another domain and just let's be neighbors, nothing more. What the register will do, it will check its whitelist, see the serial number of the device and see whether it's allowed or not. If it's allowed, then perfect. This is my register and this is my domain certificates. These are my identification, and please generate a key so I can issue a certificate for you too. Once the key is generated and it's sent back to the register starts issuing a certificate. In this scenario, if you have a small network, the register can be the one responsible for issuing the certificates for you. If you have a bigger network and you have a certificate authority within your network, well, you can relate, or you can just make the certificate authority just issue the certificate for the new device. And finally, once we issue the certificate for you, we will send it to you back. Now you are part of my domain. Now we can communicate together, and it's time to build the secure channel, which is totally encrypted, totally authenticated, where we will send the information. So what are the protection mechanisms of the secure channel? From Cisco perspective, we have two, IPsec and DIKE. IPsec is used as a backwards compatibility here. It's run on port 500, and it has been supported till like 2015. And starting from after that, we have DIKE. What's DIKE? It's Data Internet Key Exchange. It is based on IKE v2. It has the same protection and security mechanism as IPsec, but instead of having two phases to build the connection, it's just the second phase. Well, from Cisco perspective, it's always preferred over IPsec, and there is no mechanism that you can alter or just modify such an order. Yeah, so we said that we need 5 commands just on the device. So what are these 5 commands? As we said, we need to say what network do we support. So we start by identifying, like saying, well, this is my domain ID, and there is an optional command which is the whitelist. If you don't put the whitelist, then you will accept all devices. And after that, we will say who will be the certificate authority which will issue the certificate. Will it be the same device, my register, or do I have an external one? If I have an external one, all what I will put here is just the IP address of the other certificate authority. And that's it. No shutdown, start the services, autonomic start the autonomic services. So there's no much hassle, no much things to configure here, just 4 or 5 commands, and just it configures everything else. If we are speaking about, again, what are the configuration needed on the enrollee devices that will connect to this register, if we are speaking about brand new one, it's none, totally none. You don't have to configure anything. And if it's an old device that has already a connection, configuration, sorry, then all what we have to do is just one command which is called autonomic in the configuration mode. And that's it. Everything is configured for you. When we are speaking about basic configuration here, what do we mean? We mean that you will have like 3 or 4 interfaces configured on your machine. All of them are based on IPv6 address. You will be issued a domain certificate. You would have generated the key. You would have created VRF for Cisco VRF. If you have like AAA will be allowed directly. If you have in your system or in your network a syslog server, a TFTP server, anything like that, they can be inserted into autonomic and learned automatically. So you don't even need to configure where is your TFTP server, where is your radius server, what are the IPs. No, you can just, autonomic network is using MDNS, so you can just put the services what you want in the MDNS, and it will be just advertised, and it will be known by all devices within your network. And if you would like to put maybe like a further configuration on this device, you would just put a device name or a configuration file with the serial number of the device on the TFTP server, and it will be detected automatically, and you can even have further an additional configuration if you want. After we had a brief idea about the configuration and what do we need really to implement, or just like the simple 5 commands, comes the question, are you in control? Do you know really what's running inside your network? Well, in order to try to know something like that, we said like, okay, let's see on Wireshark what's going on. And what we have seen is something like this. Well, Wireshark couldn't analyze any of the packets. We are seeing an LLC. This is a layer 2 technology. Well, theoretically, I expect it to have a layer 2, which is channel discovery, a UDP service, as we said, and after that, secure channel, either DIKE or IPsec. But I don't see anything. Although Cisco explained the technology, but never said about anything about the protocol itself. And comes the question, if we would like to understand, and it's time to reverse engineer and understand what's the significance of each and everything that we see in our network to make sure at least that we are secure. The first frame that we usually see is the channel discovery, and comes the question, how do we start? At least we know that the first thing that we will see is the Ethernet frame. But which Ethernet frame? we have 3 kinds. Well, by looking on those bytes, we understand that this is not an Ethernet 2 frame, and by looking on those bytes, we understand this is a snap frame. So at least we have a rough idea how to restart. We now have a snap frame. So this is the destination MAC address, source MAC address, and the frame length, snap frame identifier, and after that, the organization unique identifier, and this is the unique identifier of Cisco, saying like, we are the one who implemented this protocol. And after that come what we believe the autonomic protocol ID. To this point, we have finished the Ethernet frame or the snap frame, and comes the question how we continue further. Well, we believe that this protocol is based on this header. We can understand and analyze the protocol based on this header. It somehow has some fixed part, and after that TLVs. TLVs, it means that it's type length value, and you just introduce or define new types and just put it with a variable length, and you can add whatever you want. So to do something and continue analyzing the protocol, we can see it as the following. We have the version here for the channel discovery, which is 1, and some fixed bytes here. And after that, we have the state. For the state, it means which phase are we in the protocol. Well, we are just starting, so the phase here is O1. We have after that the frame some factory default bytes, which are fixed bytes that never change, and have after that the opcode. The opcode means what is the significance of this frame, what is the role this frame is playing. For the channel discovery, these are the available opcodes. It's either like an announcement or reply or just keep alive, so they're being sent every now and then. After that, we have the header length and some reserved bits, they never change. And after that, we start again with the type and length and value. For the available types for the channel discovery, here they are. Some for the UDI, what we mean by UDI is the serial number of the device plus the model, or the receiver, or if we are speaking about interfaces. Well, this is quite simple for the channel discovery, but what about the adjacency discovery? It's a little bit bigger. We understand that here we have a UDP service, but how we start? It's the same idea. We have a snap frame, and after that comes the problem that the reason that Wireshark cannot analyze the packets, and this is a customized channel discovery header. Cisco has added this as a layer, like a layer 2.5, so they can just communicate, they can just have their own layer, but other devices or Wireshark cannot understand this. And here, somehow it's very close from what the one we have just seen, with the minor differences. The state here is O5, which means there is an adjacency discovery coming after that, and we have the next ether type, which is an IPv6 ether type. It means like what's coming next is an IPv6 header. After that, we have the IPv6 UDP service, and comes the question to analyze the adjacency discovery. Well, we believe it can also be analyzed based on the same header, but with different TLVs and different values. So same idea, here the version is 2 instead of 1. And the available states, well, we have multiple here. It's either we are just beginning the adjacency discovery, or we are issuing the certificate, or we are just even negotiating about the secure channel. After that, we have the same idea of reserved bytes and the opcodes. For the available opcodes, it means what's the significance and what's the importance of such a packet. We can see the table we have on the slide here. After that, we reach the idea of like the header length and some reserved bytes, and same idea of type, length, and value. Well, for the available types, we have big list of available types. It would have taken like 4 or 5 slides just to add them. So this is a small sample of it. Okay, by that we have finished the adjacency discovery. We have at least a bit of rough idea what do we have running in our network. And here comes the question. Secure channel, we say DIKE, is a protected one. What if you are a little bit curious to know what's really running inside your tunnel? From Wireshark, here it is. We can know that this is a DIKE because of the ports. But comes the question, how do we know what's running inside the header or inside the tunnel? Well, maybe the solution for this problem can be with this device. This is an ME3600X. This is one of the first devices that supports autonomic network. It starts in 2014. Okay, but how can that help? Well, if we have an IPsec for backwards compatibility, maybe it means that only DIKE has been supported in the newer system, in the newer operating systems. And it hasn't been before. Okay, also you have an IPsec. Can you break IPsec? Come on, we are speaking about Cisco closed devices. What shall you do? And the solution for this is simply IPsec null. Well, IPsec null allows you just to configure zero encryption and just allow authentication on the packets. So now you can see each and everything running inside your tunnel. Well, this is a packet that you can only see inside the secure channel. It's an RPL, and this is the routing protocol of autonomic network. It's used usually in IoT networks. And we can see here is the GRE, and we can see the ESP, and that is literally in clear text. Now comes the fun part. Is it secure? Now you understand the bytes, you understand the significance, you understand the values. But is it secure? Can we start deploying it? Well, it eases lots of our problems, but can we do it? And for that, somehow we will have like a live chat with us today. So we will try to check, see everything, and if we have any problems, we'll just try to support here. My first idea was to see, well, we said like if you are from a different domain, you cannot connect to mine. We would just be neighbors. So I wanted to start or put this into practice, and I asked Poetic here just to get me like a brand old device that we have. Yeah, and as we can see here, it's just called different domain. If we would like to see what domain does it belong to, we will write show autonomic control plane. And now show autonomic device, sorry. And we can see here that the domain name is called different. It's just different. My original domain name is called ERNW, and I believe once I connect them together, they will never connect. But I'm a little bit curious, so let's try to connect it. So yeah, Wojtek, please try to connect them together. And yeah, I expect somehow like, just layer 2 connectivity, nothing much here, the interface will come up and everything will be good. So yeah, I don't expect much here. So yeah, I see the line came up on the interface. Okay, I see the certificate has been validated and we are getting some configuration here. From Cisco perspective, this shouldn't be. Somehow there are two different devices from two different domains. How can you connect them together? Yeah, please take me back to the support. So, hey, I just connected two devices from two different domains and they are working together and they just have a connectivity and they built even the secure channel. How can that be? And honestly, from Cisco perspective, they were quite fast in some of the vulnerabilities that we have reported to them. They really provided very good support. So they checked with the business unit, and although it's not there in the documentation, but Cisco decided to change a bit of the documentation and said, well, if they have a certificate signed by the same certificate authority, although we are from two different domains, we will build the secure channel. But come on, this is against what you have written in the documentation. This shouldn't be. And Cisco's simple answer was, okay, we will add this feature in the future. Okay, what's the implication of this? What's the problem of that? That if you have a certificate, you never check your whitelist. I can always just get into your domain, and you have nothing to do to stop me, because I have a certificate. It's maybe an old certificate, but I can always join. In order to stop me, you have to destroy your whole network, then build it again, or change even your CA. Okay, but you know what? Even if someone connected to my domain, I can just revoke the certificate. It's not that hard for me. I'll just go to the register or the certificate authority in this example and just write, like, if you can please just go to the register, and I'll just like write crypto PKI server, and the server of Autonomic Network is called ANRA-CS, and I'll just write revoke, and that's it. I'll just write like, okay, this certificate is no longer valid, please revoke it, and everything will be fine. It's not a big deal here. Okay, well, we tested this, and if you can go to the presentation, please. When we tested this and when we said that to Cisco, well, we tried to revoke the certificate, but nothing happened. Every time they are still in our connection and now in our domain, they said to us, have you tried it on internal or external? Have you tried on just the register, or you have your dedicated? Well, if you tried it on internal, well, it's not supported. But if you have tried on external, well, this is a CVE. So we tried it on both, it didn't work. And the implications of this, that there is no way to kick someone out of your domain. If any of your nodes have been compromised, then it's a game over. You cannot stop them, you just have to destroy everything that you have built and start from the beginning. Okay. You know, I have full control on my network. I believe none of my nodes will ever get compromised. All what I care about that I have a really stable and secure connection. And if we go just to one of the devices for the register, for example, and we type something like show autonomic control plane details, we can see that the secure connection has been up here for about 3 minutes and 21 seconds. So we have a secure and running connection, and that's all what I care about. Why should I care about something more? I hear Wojtek here is typing something. Well, I see that he's saying that he will just reset my communication. I think it's not that simple, come on. This is the main thing. And even he says something like, check your watch. Okay, so I see here that the tunnel interfaces are really getting down. That anyone inside your network can just drop the communication, can just reset your communication. And by saying just go to Wireshark, so please take me to Wireshark. This is the RPL packets. RPL packets can never ever be seen outside of the secure channel. This should be totally secured and encrypted. Well, the problem is, if we can go back to the presentation, that a remote attacker can just reset your secure connection whenever he wants. Not only this, everything sent inside the secure channel will be just sent in plain text. So neither you will have stability, neither you will have confidentiality. Everything sent there is seen in plain text. Well, Cisco just published the advisory today, and as per Cisco, the reason of this vulnerability is something unknown in the source code. So if you are interested and you would like to check the advisory, well, Cisco, there is no workaround for that. There is no fix for that. Cisco even don't know where the problem is in their source code. So yeah, there's nothing in our hands that we can do for that. So it's a little bit scary, because now you will never have ever a stable connection. An attacker can always, see whatever you are sending inside the secure channel. But at least I can run services on this device. At least I can have other services and it will be fine. So I think there will be no problem in that. And for here, we have a small video that Wojtek is trying to show me. And I see that he's trying to reset the secure channel. Yeah, come on, I understand. This makes a problem. My channel is not secure, can be reset by anyone. But he's also trying to ping. No way, don't try to imply that my device will go down. It's not that simple and not that easy. Just by resetting the devices or resetting the secure channel, my network will go down. Let me see. You see, my device is still up. I don't understand why you're just showing us this video. My network is secure, you know. So, okay, I'm just watching it with you. And yeah, this is the second iteration. You're just resetting my channel. I won't think it will cause any problem for me, and everything should be running fine. Yes, ping it, it's up. My network is secure. My network is stable. Don't think about it. And the network is crashed. Regardless of anything you have, resetting the secure channel even crashed the device that you have. So any in-release that you have inside your network can be easily crashed. So it's not just about the connection itself. Now the attacker can take the devices down. So if you can take me back to the presentation, please. The attacker, by resetting the secure channel multiple times, the node eventually crashes. And this is another CVE that we have for today. Same idea. When you check with Cisco where the problem is, it's something unknown in the source code that we don't know. There's no fix, there is no workaround, the nodes will always crash. This attack takes about 15 minutes. That's why we thought about having a video instead of us just running it for 15 minutes. But you know, okay, you crashed my devices, you crashed my connection. My register is the strongest point in the network. Yes, no one can touch it. It's the controlling point where I put all the communication and everything is running on it. So if you please go to the register, show them how long it has been up. So if you could just please, connect to the register and write show version include up. You see, it has been up for 51 minutes since we started. Nothing can touch it, nothing can do anything to my register. Okay, see, it's typing something, crashing my register. It's not that simple. Even my register has crashed. So now I don't have a register, I don't have in-release, I don't have network even, you know. So yeah, thanks. Just take me back to the presentation. So by just sending in-release name as null byte or space byte, you can just take the register itself down. Somehow I have no other option. I don't have network anymore, neither register nor in-release. I'll just disable autonomic network. Sorry for that. So yeah, please disable autonomic network on my devices. We will just go to the new device that we just had, and we go to the configuration mode, and we just write no autonomic. We would just run our IPv6 normally, so we go to interface gig 0/0/0, and just put a simple IPv6 address for the sake of presentation, something like IPv6 address, and 2001 ::1/64. And I will go to my second device, like the different domain, and I have no other option except to disable autonomic services here too. Go in configuration mode saying no autonomic. And I will just go to interface gig 0/0/0 and put like the IP address. Yeah, IPv6 address 2001::2/64. Yeah, I have no other option. All my devices, all my networks already done. So, you know what I feel now? I feel that I am safe, really safe. Nothing can, yes, affect me. Yeah, don't look to me like that, right? That's safe, and even with that exclamation mark. Yes, nothing can touch my network, nothing can touch my devices. I haven't configured anything on them. Come on, it's just an IPv6 address. And everything is crashed. Well, that's what I call the death kiss. This is my favorite attack. Regardless, you have autonomic services or not, just knowing your IPv6 address, we will crash, the network will be crashed. We don't need anything more, just knowing the IPv6 address, and the network will be down. The whole device will be down by just sending one single packet. In order to stop this attack, you either have to upgrade your system. As per Cisco, 161 operating systems are affected by this attack. So please check if your operating system is affected by this. You don't have to run autonomic services. Just the idea that your operating system supports it makes it vulnerable. Autonomic services has been into the market for 3 years from now. If you would like to stop this attack, you need to put an access list on each and every reachable IPv6 interface to drop anything on port 4936 and 48. Else, the device can be crashed. Link local or remote or globally, it will be crashed. To conclude today's presentation, we have spoken about autonomic network. We have spoken about the technology that you can use to ease your life. Well, although it's quite good, and we have reversed all the multiple phases of it, although it's quite good, somehow it has severe vulnerabilities that can affect your network and affect your domain. We have crashed the secure connection, we have crashed the in-release, we have crashed the register, we have crashed everything within this network. And after that, even if you disabled everything, your devices will be crashed by just knowing your IPv6 address. Finally, if you would like to get your hands dirty, you can just download WireEdit. This is the first application to use our analysis. And you can download a virtual image from Cisco devices. It's called CSR 1000V to work on the devices and work on the autonomic network if you want to. I wouldn't have done this except with the help and assistance of Mark Hoyza, who helped me so much with the protocol analysis. And finally, if you are interested in more, I have written 3 articles on insinuator.net. You can go there, check them, write me a mail, or just like we speak outside and tell me if you have any questions or have any ideas. That's all from my side. Thank you, Wojtek, for the help, and thank you for your attention, and that's all.